Okay, so we have a couple of exercises we need to take care of, and basically in these first 9 exercises, what we want to do, basically we want to find the coordinates of the foci. So basically you want to find your F1 and F2. You want to find the vertices. You want to find the length of the major and minor axes. You want to find the length of major and minor axes. You want to find the eccentricity, or E, and you want to find the length of the latus rectum of your ellipse. So these are the things that we want to find out here. I'll make a screenshot here. And basically the ellipse that we have is x squared over 36, x squared over 36 plus y squared over 16 is equal to 1. So in this ellipse, basically, as you can see, the coefficient of x squared has a larger denominator. That means that the major axis is along the x-axis. Since the major axis is along the x-axis, then I can basically assume that I can write the equation of this ellipse as x squared by a squared plus y squared by b squared is equal to 1. And that means that basically a squared is equal to 36 and b squared is equal to 16. And so that means that a is equal to 6 and b is equal to 4. So a is equal to 6 and b is equal to 4. So the foci are at a distance c away from the center. So now since I have my a and b, I can calculate c, meaning that I can write a squared is equal to b squared plus c squared, or c squared is equal to a squared minus c squared is equal to a squared minus b squared. So c squared is equal to 36 minus 16, which is equal to basically 20. C squared is equal to 20. That means that c is equal to the square root of 20. (36 minus 16 is equal to 660, so that's the square root of 20. So your c is equal to the square root of 20. So your foci are at, since they are along the x-axis, then they are at basically negative square root of 20 comma 0 and at square root of 20 comma 0. So that is basically the foci. Now the vertices are at a distance a away from the center. So that means that since a is equal to 6, so then you have negative 6 comma 0 and 6 comma 0 are are the coordinates of the vertices, and the length of the major and minor axes. So the length of the major axis is basically, well, here along the x-axis, where a is equal to 6, so the measure of the length, the major axis is the length of the major axis is equal to 2a, which is equal to 2 times 6, which is equal to 12 units. The length of the minor axis, is equal to 2 times b, which is equal to 2 times 4, which is equal to 8 units. And the eccentricity E, which is equal to c to a, is equal to square root of 20 over 6. And the length of the lattice rectum is equal to 2 times b squared by a, I suppose. 2 times b squared by a. Is equal to 2 times b squared by a, which is equal to, basically b squared is equal to 16. 2 times 16 divided by 6. Divide by 2, you will get 1. Divide by 2, you will get 3. So that's 16/3 units. 16/3 units. So then if I do the answers, the foci are at negative plus or minus square root of 20, comma 0. The vertices are at negative 6, and positive 6, comma 0. Major axis is 12 units. The minor axis is 8 units. The eccentricity is square root of 20 divided by 6, and lattice rectum is 16/3 units. So that was the first one. The second one is x squared divided by 4 plus y squared divided by 25 is equal to 1. So since over here basically the coefficient of x squared has a smaller denominator, then I can write, and that means that this is b and this is a, meaning that I can write the equation of this ellipse as x squared by b squared plus y squared by a squared is equal to 1. And so b is equal to square root of 4, which is equal to 2, and a is equal to square root of 25, which is equal to 5. Now the things that we want to figure out here are basically the foci. So the foci are at the distance, and you see that basically your major axis is along the y-axis, So now the foci are at distance c away from the center. So c I can calculate from here. I can write basically a squared is equal to b squared plus c squared. That means that c squared is equal to a squared minus b squared. That means that c squared is equal to a squared, which is 25, minus 4, which is equal to 21. C is equal to the square root of 21. So c is equal to square root of 21. Now square root of 21 is C, so that means that the foci are at they are along the y-axis, so the x coordinate of them are going to be equal to 0, 0 comma negative square root of 21 and 0 comma square root of 21. These are your foci. Then you have your vertices. Your vertices are at a distance a from the center. So your vertices would be again along the y-axis. That the x coordinates are 0, 0 comma 5 and 0 comma negative 5. Then you have the length of the major and minor axes. So the length of the minor axis, for example, is equal to basically 2 times b, which is equal to 2 times 2, which is equal to 4 units. The length of the major axis is 2 times a, which is equal to 2 times 5, which is equal to 10 units. The eccentricity is equal to c divided by a, which is equal to square root of 21 divided by 5. And the length of the latus rectum is equal to 2 times b squared by a, which is equal to 2 times, so b squared is 4, 2 times 4 fifths, 2 times 4 fifths, which is equal to 8 fifths units. So that is basically question number 2. Question number 2, the foci are at these 2 points. These are your vertices, 10 units and 4 units, square root of 21 fifths and 8 fifths. I would skip these problems, but I'm not going to do that, because there is usually almost always there is something here that you want to learn, so you don't want to skip these problems. Okay, so the next question that we have here is question number 3, which is, you have basically an ellipse x squared over 16 plus y squared over 9 is equal to 1. And basically what you want to basically you see that the coefficient of x here has a larger denominator, so that means that your ellipse is the major axis is along the x-axis. The major axis is along the x-axis, and so I can write x squared by a squared plus y squared by b squared is equal to 1, and so a is equal to 4 and b is equal to 3. So if basically these are the values for a and b, you can write a squared plus is equal to b squared plus c squared. That means that c squared is equal to a squared minus b squared, which is equal to 16 minus 9. 16 minus 9 is equal to 7. 7 plus 9 is equal to 16. So c is equal to the square root of 7. So c is equal to the square root of 7. So now I have my ABC. so I can calculate all of the things that I need about this ellipse. So I need the two foci. So basically, since the major axis is along the x-axis and the foci are at a distance c away from the center, then the foci are at basically square root of 7, 0 and negative square root of 7, 0. Then you need the vertices. The vertices would be basically again along the x-axis, so at a distance of a from the center, that would be negative 4, 0, negative 4, 0 and 4, 0. And this is wrong. This is negative 7, 0. So these are the vertices. Then you have the length of the major axis. So I write it as major axis, and the length of that is basically 2 times a, which is equal to 2 times a, which is equal to 8 units. The length of the minor axis is 2 times b, which is equal to 6 units, and the eccentricity of this ellipse is equal to c by a, square root of 7/4, square root of 7/4, and the latus rectum of this ellipse is equal to negative, and there is no negative, I'm sorry, there is 2 times b squared by a. So that is basically 2 times 9 over 4, and that's 9/2 units. So number 3, basically your foci are at plus or minus square root of 7, 0. Your vertices are at negative and positive 4, 0. Your major axis is 8 units, 6 units, and square root of 7/4 and 9/2. So these are all the same story. So I'm going to skip the next problems, and we can safely skip these problems and go to the next set of problems, which is in each of the following exercises 10 to 20. Find the equation for the ellipse that satisfies the given conditions. So for example, let's say that your vertices are at plus or minus 5, 0, and your foci are at plus or minus 4, 0. So as you can see, basically your vertices are along the x-axis, your foci are along the x-axis, so that means that the major axis is along the x-axis. Since that is the case, I can write x squared divided by a squared plus y squared divided by b squared is equal to 1. So then all I need here is a and b. Now your vertices are at a distance a from the center, so that means that your a is 5. Your a is 5 and your c is 4. Your C is 4 because your focus is, basically your foci are at the distance C units away from the center. So then I can write A squared is equal to B squared plus C squared, which means that B squared is equal to A squared minus C squared, which is equal to 25 minus 16, which is equal to 7. 25 minus 16 is equal to 25 minus 10 is equal to 15. 15 minus 6 is equal to 9. I'm sorry. Is equal to 9. So that means that B is equal to 3. So if your B is equal to 3, then you can use A and B in this equation and write x squared by A squared 25 plus y squared by B squared, which is by 9, is equal to 1, and that is the equation of your ellipse number 10. Number 10. That is basically the equation of your, the equation of your ellipse. So the next question that we have is, for example, let's say that your vertex is at 0, plus or minus 13, and your foci are at 0, plus or minus 5. So as you can see, these are all along the y-axis, the vertices and the foci. So that means that the major axis is along the y-axis. So that means that I can write x squared by b squared plus y squared by a squared is equal to 1. And so all I need right now is just a and b. So this number, this number over here, this value is the value of a, of course, because your vertex is a units away from the center. So your a is equal to 13, and your c is equal to 5. So then I can write basically, I can write a squared is equal to b squared plus c squared. That means that b squared is equal to a squared minus c squared, which means that b squared is equal to 169 minus 25, and 169 minus 25 is equal to 444. Is equal to 144. That means that b is equal to 12. Your b is equal to 12. So then you can write, for example, x squared by b squared 144 plus y squared by a squared, which is 169, is equal to 1. And that is, for example, the equation of your ellipse number 11. X squared by 124 plus y squared by 169 is equal to 1. So we already know how to solve this kind of problem. Let's see a different type. And there is, for example, another type of problem that says that you want to find the equation of the ellipse that, for example, that ends of major axis are plus or minus 3, 0. ends of major axis are plus or minus 3, 0, and ends of minor axis are 0, plus or minus 2. So basically you can see that, for example, over here your major axis is along the x-axis. Your major axis is along the x-axis, and so of course the ends of the major axis are basically a, so that means that your a is equal to 3, and the ends of the minor axis are basically these values are, this value is basically the value of your b. The value of your b is equal to 2, for example. So since your ellipse is along the x-axis, you can write x squared by a squared plus y squared by b squared is equal to 1. And then you have these values over here. You can write x squared by 9 plus y squared by 4 is equal to 1. So that was, for example, question number 13, which is, that's how you, for example, solve this kind of problem. Or another type of problem, for example, let's say that you have the length of the major axis is basically, the length of the major axis is 26 units, and the foci are at plus or minus 5 comma 0. So if the length of the major axis is 26 units, you know that at the endpoints of the major axis if, for example, now let me start this way. Basically you can see that your foci are along the x-axis, because these points are on the x-axis. So since your foci are along the x-axis, then basically, since the foci are along the x-axis, what that means is that then your major axis is along the x-axis. And what that means is that if your major axis is along the x-axis, the endpoints of the major axis are basically negative a comma 0 and a comma 0. And of course the length of the major axis is 26 units. So 26, if you divide it by 2, that will give you basically the value of a here, because if you calculate the distance between these 2 points, you will get basically, and the distance of these 2 points, you will get the value of a over here. Meaning that, suppose that I use the distance formula, I will get the square root of, for example, negative a minus a whole squared plus 0 squared, for example, is equal to the distance of these 2 points is supposed to be 26 units. So then negative 2a whole squared, the square root of that is equal to 26, and the square root of basically 4a squared is equal to 26, and so 2a is equal to 26 is equal to 26. That means that a is equal to 13. And exactly what I said, if you divide this by 2, you will get the length of the value of your a. So that means that your a is equal to 13. Now your foci are at these 2 points, and so this is basically the value of your c, because basically your foci are c units away from the center. And so now that you have all of this information, you can use this as, for example, a squared is equal to b squared plus c squared. So b squared is equal to a squared minus c squared. And so b squared is equal to 169 minus 25, which was something like 169 minus 149, 144. So b is equal to 12. So now if your b is equal to 12, then what that means is that since we said that the major axis is along the x-axis, I can write x squared by a squared plus y squared by b squared is equal to 1. And so x squared by 169 plus y squared by 144 is equal to 1, and that is the equation of the ellipse. Number 15 is basically this equation, which is the right answer. Now let's do another different type of problem, which is for example, let's say that your question number 17. Question number 17. So, okay, so the next question is, for example, let's say that your foci are at plus or minus 3, 0, and your a is equal to 4. So basically you know that your a is the distance from the center to the basically to the edge of the ellipse, meaning to the it's half of the length of the major axis. So now basically if a is equal to 4, and if your foci are on the x-axis, you can see that over here your foci are on the x-axis. So that means that your major axis is along the x-axis. Your major axis is along the x-axis, and so based on this, I can write x squared by a squared plus y squared by b squared is equal to 1. So I have already my a over here, already basically ready over here, and b is what I need to calculate. And so, of course, based on this, I know that my a is equal to 4 and c is equal to 3. Because your foci are at a distance c from the center, and so I can write a squared is equal to b squared plus c squared. That means that your b squared over here is equal to a squared minus c squared, which is equal to basically 16 minus 9, which is equal to 7, which is equal to 7. So your b is equal to square root of 7. So now if b is equal to square root of 7, then you can write your, you know your a, you know your b. So then you can write x squared by a squared, which is equal to 16, plus y squared by b squared, which is equal to 7, is equal to 1. And that is the equation of the ellipse that you have. That was question number 17, for example. 16, 7, 1. Now, as another example, suppose that, for example, you have this information. So suppose that you know that your b is equal to 3 and your c is equal to 4, and the center is at 0, 0 at the origin, and your foci are on the x-axis. So if that's the case, if your foci are on the x-axis, that means that your major axis is along the x-axis. Then you can write x squared by a squared plus y squared by b squared is equal to 1. And you have your b, let's calculate a over here. So a squared is equal to b squared plus c squared. So then a squared is equal to 9 plus 16, which is equal to 25. So then I can write x squared by a squared, which is 25, plus y squared by b squared, which is basically 9, is equal to 1. And that is the equation of your ellipse. Question number 18. So these seem to be simple. There is no problem here. And there is one more type of problem that we can probably do, at least one of them. So for example, you know that your center is at 0, 0, and the major axis is along the y-axis, and the ellipse passes through these points, 3, 2 and 1, 6 and 1, 6. So based on, you can write basically two equations. Since I know that the major axis is along the y-axis, then I can write x squared by b squared plus x squared by b squared plus y squared by a squared is equal to 1. And now this ellipse goes through, for example, this point, 3, 2. So I can write basically 9 by b squared plus 4 by a squared. So 9 by b squared plus 4 by a squared is equal to 1. And I call this equation number 1. Then the same ellipse goes through this point as well, 1, 6. So I can write basically x squared 1 divided by b squared plus 36 divided by a squared is equal to 1 again. And I call this equation number 2. Now to solve these two equations, you can form a system of equations using these equations, but since the variables are second degree of variables in the denominator, I do need to do substitution here, meaning that I take 1 by a squared as, for example, x, and 1 by b squared, take it as y, and then substitute it in these two equations, meaning that then you can write 1 gives you 9 times 1 by b squared is equal to y, so that's 9y. 1 by a squared is equal to x, so that's 4 times x is equal to 1. And number 2 gives basically y, and 36 1 by a squared, so that's 36 times x is equal to 1. Now I can multiply this equation down here by a factor of 9. So I can write this equation as it is, 9y plus 4x is equal to 1. Multiply this equation by 9, I will get 9y plus 36 times 9 is equal to 9 times 6 is equal to 54. 27 plus 5 is equal to 32. 324. 36 times 9, 324. So that's 324x is equal to 9. Now I can add these two equations together. Negative, negative, negative. Add these together, I'll get negative 324 plus 4 is equal to negative 320 is equal to negative 8. And of course there is an x over here. And x is equal to 8 divided by 320. And this is divisible, of course. 8 divided by 320 is divided by 2, 4, divided by 250, 160. And 160 divided by 4 is equal to 40. So that's 140. 1/40. 1/40. That is the value of your x. Now I can use, for example, this equation over here. For example, write 9y plus 4x is equal to 1. And then write 9y plus 4 times x is equal to 4 divided by 40, which is 1/10, is equal to 1. And then 9y is equal to 1 minus 1/10, which is equal to 10. 10 minus 1. So 9y is equal to 9/10. 9y is equal to 9/10. And so basically y is equal to basically 9 divided by 90. Y is equal to 9 divided by 90, which is equal to 1/10. So y is equal to 1/10. Now if I substitute them back here, we said that basically y over a squared was equal to x. So x is equal to 1/40. So 1/40 is equal to 1 over a squared. That means that a squared is equal to 40. And that's basically all I need here. I don't need to calculate a. And of course, 1 over b squared is equal to y. And y is equal to 1/10. So 1 over b squared is equal to 1/10. So that means that b squared is equal to 10. And that is all that I need here. A squared 40, b squared 10. And over here we said that x squared by b squared, we said that x squared by b squared plus y squared by a squared is equal to 1. So then I can write x squared by 10 plus y squared by 40 is equal to 1. And that is the equation of your ellipse.